So, now we are coming to the next topic, and that is compounds of hydrogen, which are generally known as hydrides. And these hydrides are of many type, from binary to MMHN type, that is number of element where the M and N are the numbers, and which are generally categorized into three major category. One is classified into, that is, saline hydride or ionic hydride. Other is metallic or interstitial hydrides, and then third one is molecular or covalent hydride. The saline or ionic hydrides are the most of the S block element combines with hydrogen to form a compound which is ionic, which are non-volatile, non-conducting, crystalline solid, and they are said to be ionic hydrides or saline hydride. But there are certain uh, ionic hydride which undergo polymerization to get converted into covalent polymeric structure. For example, BeH2, MgH2, they become covalent hydride by virtue of polymerization. Then we come to the next part, and that is metallic or interstitial hydride. The elements of 3, 4th, 5th D block element and F block element. The metallic hydrides in group 6th, only chromium forms hydride CRH, which is metallic, otherwise 7, 8, and 9 do not form hydride. This region of the periodic table of 7th group is known as hydride gap example. For example, 325, scandium hydride, yttrium hydride. Now there are the certain compounds, and but the others, where when we go for their composition analysis, we found that we have a different kind of variation. For example, zirconium hydride. Now, zirconium hydride ZrHX. Now, X value varies from 1.30 less than or equal to or less than or equal to 1.75. Now, say with titanium hydride, TIX, TIHX. Here, X value varies from 1.8 less than or equal to or X or less than or equal to 2. That means varies from 1.8 to 2. That means it has a variation. They do not have a fixed value, and basically this is just because of the hydrogen is occulted inside them. They do not actually form a covalent bond or ionic bond, they form a van der Waals bond in them. Now we come to molecular or covalent hydride. When we talk about covalent hydride or molecular hydride, generally the non-metals and the certain metals, they form a covalent bond with hydrogen and they form the molecular covalent hydride. Now this molecular covalent hydride is of three types. One is electron rich, other is electron precise, and then third one is electron deficient. Electron rich are those which contains lone pair. For example, H2O, it has two lone pair. Ammonia, it has one lone pair. HF has three lone pair. Then electron precise. The hydrocarbon, saturated hydrocarbon, are the example of electron precise because the fixed number of electrons are there in the compound, they are forming a bond, there is no vacancy, there is no extra electron, there is no empty orbital is there, so such are said to be electron precise. Where lone pair are there, they are electron rich. When there are no electron or no empty space, no lone pair is there, they are said to be electron precise molecular hydride. And then third one is electron deficient molecular hydride. For example, boron family compound. They are uh, taken to be as electron deficient because when we take the example of BH3, you will find that one orbital is vacant and that undergoes for the formation of the banana bond and then making this type. Then we come to various types of hydrogen on popular basis for the chemist. But let's go for one by one. One is atomic hydrogen. Atomic hydrogen is produced when hydrogen molecule under the influence of electric arc break up into two H or two hydrogen atom. Nascent hydrogen, when some reaction is taking place, and then at that time H plus ion is liberated and that combines with the electron to form H. That means we can say a newly developed hydrogen atom or newly developed hydrogen. So this is known as nascent hydrogen. And then we already know that the molecular hydrogen is a diatomic molecule which is existing in the two forms, that is ortho and para. Now we will take the next topic, and that is uh, types of water.